All right, so today we're going to move on with our exponent rules, and we're going to talk about dividing polynomials, which means the powers are actually going to be subtracted instead of added. And it's important for us to kind of figure out kind of the pattern and kind of what's happening. And it really does make a difference in terms of where the bigger variable is, okay? And we're going to have to do some simplifying of fractions, so I would suggest having your Desmos calculator open as you work today. And let's go ahead and do a quick little review of what we've been working on for the last couple days with the product rule and the power to power rule. So go ahead and hit pause and see what you can do with these two problems. All right, here we go. 2 times -4, that's a -8. And then remember, I am adding my powers if I'm moving this direction. So 2 plus 3 is 5b. 3 plus 6 is 9. So I have -8, a5, b9. Now, if I look at this one, I see I have a distribution. I have a product rule here. So I need to distribute to all of these before I do anything else. So 3, 1 times 2 is 2. X, 2 times 2 is 4. And y, 3 times 2 is 6. And I'm going to go ahead and drop down the 3x3, y5. Now I have to put these guys together. Now I do know that this is a power of 1. And I also know that I'm multiplying those. So I can, since I know that they are actually the same base, I can add the exponents, and 2 plus 1 is 3. Or I can just go ahead and evaluate that. So 3 squared times 3 is 27, which is the same thing as this. So 27. And let's go ahead and go on to our variables. So 4 and 3 is 7. Hey. And 6 and 5 is 11. Stop. Sorry about that. So I have 27, x7, y11. Okay, let's take a look at what is happening when we are talking about division with powers, okay? So I want to break this down again in kind of what we know we have, and then look at some simplification to see what's going on. So 3 to the 4th is actually 3 times 3 times 3 times 3. There's 4 of them. And this is 2 of them. Well, what do I know about anytime I have a number divided by a number? That's actually 1. Okay, so I know that these 2 would actually cancel out, and so would those 2. So I'm left with 2 3s, which would be 3 squared, which is 9. Okay, let's take a look at the next one. So that has 3 4s and 2 4s. And I see that these 2 would cancel out, and I'm left with 1. Okay, which is just 4. Well, the next one has 5 2s, 2, 3, 4, 5, and 2 2s on the bottom. And again, they cancel out, and I'm left with 3 2s, which 2 to the 3rd I know is 8. So do you see a pattern going on? Do you see a pattern? Hopefully you're noticing that 4 minus 2 is 2, and 3 minus 2 is 1, and 5 minus 2 is 3. So what we're actually doing is we're subtracting powers. Okay, we're subtracting powers, and that's how we're coming up with what's left. Okay, and it does make a difference in terms of where the bigger number is. Okay, where the bigger number is. So for example, this one, I have 6 on top and 3 on the bottom. 1, 2, 3, 4, 5, 6, 1, 2, 3. If I cancel those out, I'm left with x3 on top and really technically a 1 on the bottom. Okay, and I know that 6 minus 3 is 3. Well, if I was to flip that and have 3 on the top and 6 on the bottom, that would change my answer, because if I cross these out, where are the x's left at now? They're on the bottom. So I have to pay attention to where the bigger number is, okay? Well, what about 4 minus 4? Well, 4 minus 4 is 0, and I know that anything to the 0 power, let's check that over here, 3 to the 0 power is 1. 3 to the 0 power is 1. Okay, so let's see what you can do with these couple, and keep in mind that like bases go together. Okay, like bases go together. We're going to kind of split them out into pieces and kind of look at them in sections to decide who's on top, who's on the bottom, and kind of what's left. Well, the first one's pretty easy because I see that there are 5 on top and 2 on the bottom. So 5 minus 2 would give me 3 on the top. And again, if I was to work that out, there's 5, there's 2, those cross out. I'm left with 3 on the top. Okay, so this one has 2 different ones. I'm going to go ahead and split these out. So I have m to the 7th, and I have an n5, n2. Notice how I added a 1 here. Okay, and we have to decide where these are going to end up. So 7 minus 1, that's 6. And who's the bigger number? Yeah, it's on top. So n to the 6 is going to go on top. What about the n's? Well, I have a 5 and a 2. 5 minus 2 is 3. The bigger number is on top. So technically those are over 1. So I can go ahead and write that as m6n cubed. Okay, try this next one, see what you can do with it, and then we're going to look at what happens when we all of a sudden throw some numbers in there. All right, let's see how you did. So x3, x squared, y7, y6. If I subtract my powers, I'm left with x to the first on the top and y to the first on top, which is really just xy. All right, now let's take a look at this next one. I'm going to break this out into our 3 pieces, and I'm going to go ahead and add a 1 there so I don't forget that there is a power of 1. And let's do our numbers first. So this is actually a division. It's a fraction. So I need to simplify it. So 81 divided by 9 gives me 9, which is technically 9 over 1. Okay, 9 over 1. 8 to the 8th, 8 to the 5th, 8 minus 5, that's 3, and they're on top. 3 minus 1, there's 2 on the top. So all of this is over 1, so the answer would be 9a3b squared. Okay, go ahead and try the next one. Then we're going to look at what happens when all of a sudden our bigger numbers are on the bottom. All right, let's see how we did. So with my 3's, my m's, and my n's. Okay, well, 3 divided by 3, that's gone. And m3, that's gone. So that really leaves me just with my n's. Well, 3 minus 2 is just 1. So that is really just n. All right, now let's take a look at this one because all of a sudden we have a bigger number on the bottom. Okay, bigger number on the bottom. So let's start with our fraction. So 3 divided by 18, 3 divided by 18, and I'm going to hit the fraction key. And it tells me 1 over 6. So the 1 goes on top, the 6 goes on the bottom because this is a fraction. Okay? What about my r's? 4 minus 3, that's 1. The bigger number is on top, so it's going to go on the top. What about my s's? Well, this would be ss and 4 s's, 1, 2. They're on the bottom. So my s squared actually has to go on the bottom, not the top, because this is where my biggest number is. So this answer is r, 1r, 6s squared. 1r divided by 6s squared. And I could certainly just put r over 6s squared. I don't have to write the 1. Okay, so take a minute, see if you can make some headway on these. Keep in mind that sometimes things are going to be on the top, sometimes things are going to be on the bottom. You need to simplify your fractions. So simplify away, and I will catch up with you. Okay, let's see how you did. Again, I'm going to write these in pieces so I can look at each one. So 5 divided by 15. 5 divided by 15. If I hit the fraction key, it gives me 1 over 3. And then I'm going to take a look at my x's. So 7 minus 3 is 4. The biggest number is on top, so it's going to go on top. 3 minus 1, remember there is 1 there. That's a y squared, and it's also on top. And I have a 6 and a 4. 6 minus 4 is 2. That one is also on top. So my answer can look something like this, or I can put a 1 here. So 1x to the 4th, y squared, z squared, all divided by 3. Okay, 10 over 6, x3 and x, and my y4s. Remember, there's a 1 here. So 10 divided by 6, and my fraction key gives me 5 over 3. My x's, 3 minus 1 is 2, and 4 minus 4 is 0, so those are gone. And here's my answer, 5x squared over 3. All right, let's take a look at this one because it's got numbers that are bigger on the bottom. Okay, 18 divided by 12. Whoops, clear that. 18 divided by 12. And fraction key is 3 over 2. So the 3's on the top, the 2's on the bottom. And my x's. Well, 8 minus 5 is 3, and I see the bigger numbers on the bottom, so these guys are going to go on the bottom. And 9 minus 3 gives me 6. That's on top. So my answer is 3y6 over 2x cubed. Again, you have to locate those bigger numbers, okay, the bigger powers, because that determines where the remaining variables should go. All right, now let's work on this one. So we're going to start putting some of these rules together. Okay, so we're going to pull what we've been working on for the last couple days, put it with what we're working on now, and then simplify. So I see that I have a distributed property on the outside, and I'm going to go ahead and distribute to everything on the inside first. So I'm going to add a power of 1, a power of 1, and a power of 1. So 2, 1 times 3 to the 3, a, 2 times 3 is 6, b, 1 times 3 is 3, and I still have to go to this one down here at the bottom. Okay? Then I'm going to go ahead and treat it just like I had been doing. Well, 2 to the 3rd is pretty easy. I know that's 8. And if I take a look at my a's, 6 minus 3 is 3. Here's my bigger number. So I know that's on top. The b to the 3rd doesn't have any friends. Technically, that's over 1, but I don't need to write it that way. So my answer is 8a cubed b cubed. All right, now let's take a look at this next one. So I see that I have a power rule or product rule here, and then I see I have a multiplication. So I'm going to go ahead and do the product rule first. So that's 2 squared x squared y squared. And now I'm going to multiply here. Okay, and there's a couple different ways I can do this. I can simplify within, or I can go across the top, across the bottom, and then simplify. And I think I want to do that. So let's go across the top, across the bottom, and then multiply. So I'm going to multiply these two. Okay, so 4 times 2 squared. Well, 2 squared is 4, so 4 times 4 is 16. And there's no other variables on top, so I have 16 x cubed y cubed on top. And then if I go and work my way across the bottom, I see that there's just a 2. And these are powers of 1, so 1 plus 2 is 3, and 1 plus 2 is 3. Okay, so now I can look at each piece. So I have 16 divided by 2. Well, that's an 8. Okay, so now I'm going to put 8 over 1. Just because I started as a fraction, I want to make sure that I'm not going to miss something. What about 3 minus 3? That's 0, so I don't care about those. Those are gone. And 3 minus 3 on the y's, those are also gone. So I'm left with 8 over 1, which is technically just 8. All right, so let's see what you can do with things today. Reach out to us if you're struggling. We'll work some more on division tomorrow, and we're just going to add in some negative powers and some more 0 powers, and we'll kind of go from there.